All right, so today we have Shuveb Hussain, co-founder at Unstract. Um, so their tagline on the website is automate the unautomatable. Also, no-code platform to eliminate manual processes involving unstructured data using the power of LLMs. And on GitHub, the tagline is no-code LLM platform to launch APIs and ETL pipelines to structure unstructured documents. So with that long-winded introduction, welcome to the Data Exchange Podcast, Shuveb.
Thank you. Thank you, Ruben. Glad to be here.
So let's start from the beginning. So what inspired the creation of Unstruct? And I suppose because it's no code, you might as well describe the personas that you guys are targeting.
Yeah. I think there's like a new persona that will probably get created, right? Prompt engineers, whose job it will be to do like a bunch of things. But to answer your first question, like what inspired us creating Unstruct was that we initially started out with structured data, right? When we started out, we started in late 2021. But then again, right? I mean, for the first time in the history of compute, you had large language models that could actually, they have the ability to reason, they have the ability to follow instructions. We realized that we could use both those abilities to structure unstructured data. It's a very prevalent problem. So that's what inspired us to start Unstruct.
So you said so you're targeting this emerging persona called prompt engineer, right? So what do you envision they would be doing, and how does Unstruct fit into that?
The prompt engineer persona is still something that's developing, right? So in many of our customers, what we see is that, hey, the data engineering team, the engineers themselves, they kind of double up as prompt engineers right now, at least. Right? We're not yet seeing roles that are just doing prompt engineering. I think that's probably going to take a while for that role to emerge fully. Yeah.
So the data engineer classically, so they build pipelines, right?
Yep.
So in the maybe 5 years ago, there was this rise of data engineering startups that built pipelines that basically targeted lakehouses and warehouses. So what? So you're talking about prompt engineers kind of assuming data engineering sort of tasks. So what specific tasks?
Yeah. So imagine what a data engineer would be doing with regular structured data today, right? What happens is, how do you reimagine that for unstructured data? Man, that's what we've been thinking about, right? So our goal from the beginning has been, hey, a document goes in, it could be complete unstructured document, and out comes JSON, or out comes a SQL that can write, that structured data into a data warehouse or a database, right? So that's what we've been really thinking about. That's why we say unstructured data ETL pipelines, right? So what would it take to build a Fivetran for unstructured data is something that we've been thinking.
And so then, I imagine. So let's say I'm one of these emerging prompt engineers, right? So someone gives me 1,000 PDF files. So then I use your tool, and then let's set aside the actual technology. We can dive deeper into that later. But so I use your tool, and my goal is to take those 1,000 PDF files and somehow extract structured information out of them, and then put them somewhere where I can use my standard query tools. Is that kind of the idea?
You nailed it. So that's the bridge we want to be, right? So yeah.
So then, Shuveb, so someone listening to this would say, well, that can be difficult, right? Because so if you look at the typical unstructured text, right? So the structured information buried in there.
Yeah.
I mean, it could be kind of obvious in the sense that there's tables or charts in there.
Yep.
Or it could be less obvious. So you would have to do some sort of entity extraction. So then, I guess, how do you know that you're doing it right and getting the most out of your unstructured data? So this is the classic problem, even for teams building retrieval augmented generation, right? So
That
you've
is correct.
got a lot of decisions to make, right? So how do I chunk my data? What's the embedding
Yeah.
strategy, and so on and so forth. So in this case, you're not even doing that. You're going directly to extracting as much structured information out of unstructured text. So
Yeah.
walk us through how you do that, and how do you guarantee that you're not leaving valuable gold on the table, so to speak? Yeah.
No, no, absolutely right. So, but we have to take a step back there, Ben. So see, what happens is that if you take most of the use cases today for LLMs, they're mostly the response for a LLM is mostly used for human consumption, and humans are of course very tolerant to change in formats or sentence structures and things like that, right? Now, luckily, because we output JSON, it's very easy to verify, right? So we have a technology called LLM Challenge, where we never use a single large language model in production, and we would never advise anyone do that. LLM Challenge uses two large language models, typically from two separate vendors. The first model extracts, the second model challenges. They have to come to a consensus. And these are small bits of JSON data, right? These are not sentences. So comparing results from two different large language models becomes very easy for us, right? So unless there's a consensus, we would rather fill a field's value to null rather than a wrong value. That's our philosophy, right? A null is better than a wrong value for any field.
So
That's how we
then,
do it.
you can actually, so you can take this idea and use more than two large language models, number one, but then you still have this no, precision and recall kind of thing, right? So how do I know that both of those language models may have missed an entity,
Yeah.
for example, right?
So now, it's a little bit complex than that because if you look at the real world use cases we get, right, we get documents of like scans and different orientations, bad contrasts and things like that, right? So first is we have to, have a very strong, what we call as a LLM targeting OCR. That's like a
Okay.
specialized thing now, right? So, for example, you have a lot of startups popping up in that area, Unstructured.io, Llama Parts, Redacto, and LLM Whisperer, which is our product, right? So we see a lot of that. So that's the first thing. So if you get something wrong at the OCR level, no large language model, no technology is going to
Yeah,
save you
and
there.
so actually, again, so someone doing this on their
Yeah,
own, they go to uh, if they're using Python, there might be like 30 or 40 OCR libraries, right? So,
yeah,
so
yeah.
they're gonna have to try a bunch of them. So, so even at the OCR level, you
Mm.
might already have been leaving information on the table potentially,
That
right?
is that is correct. No, that's the reason why we have computer vision based techniques. For example, to take care of contrast, to take care of orientation, and then we have machine learning techniques to detect checkboxes and radio buttons, because forms are very common for us, right? So, for example, we have insurance customers, BFSI customers, and form processing becomes very. For example, let's say someone is married or unmarried, just a checkbox. But then you'll have to, number one, detect the checkbox. Number two, you'll have to render the checkbox in a manner that large language models can interpret the checkbox, right? So there's both these things involved. So that's the lowest level layer, Ben. Then what happens is that large language models, right? Like I said, if both of them hallucinate, let's take, for example, right? What are the odds that two large language models from two completely different vendors, having probably built out of two differing architectures, will hallucinate the same value? We've never seen that in production, right? So what happens is when that happens, we set the value of that field to null, right? And then we have something called manual review queue. If there's a critical field which has been set to null, and then it can go on to a manual review, right? So that's how we do it. But the main thing really, Ben, is that I want to reiterate is that not very good to set a field's value to a wrong value, because people lose trust in the system.
So why stop at two external commercial LLMs, why not also take something like Llama, fine tune it for, let's say I'm one of these customers of yours with a form, and at some point you learn more and more about my data. You might as well fine tune the model specifically for my needs, right?
Oh, we do that all the time.
And then you'll have the two commercial ones and then a fine tuned one, and then now you have three. Trying to
the
achieve
reason,
consensus. Yeah.
no, absolutely, man. I mean, you think correctly, right? In fact, we did go down that path. One problem with using a bunch of models is cost. When we enable LLM challenge, the cost quite literally doubles, right? So we'll have to use two large language
Hey,
models.
come on, it's so cheap now. The API endpoints. API endpoints are like what is it, like cents for million tokens, right? So
Yeah, I mean, look, honestly, right? When you compare large language,
latency would be my main worry more than
that's the
anything.
second thing I was going to
Yeah.
talk about. Latency is a big problem, right? But luckily, we have to do this serially. So some people think we use two large language models to extract in parallel. We don't do that. We will use like kind of a student-teacher kind of a thing, and then we will have a dialogue between the models and then come at a conclusion. But even before that, we have customers who process millions of documents a month. These costs add up very, very quickly, right? So we'll have to be really, really careful about every token we send to any large language model, right? So that's one thing. And to answer your question, fine tuning is something we already do. So what we do is that we would look at, let's say, around 1,500, like 1,500 different results, and then we would use those to fine tune and then deploy that model. Usually, Llama 3 is what we prefer, and then that's how we go forward. You're right. Fine tuning is perfect because see, we say another thing, right? So customers generally think about, hey, what is our IP if we use our platform? But IP is really the prompts and the fine-tuning data, right? So we think that's really the IP for the customer and ultimately the fine-tuning models they have.
So let's take a step back and talk about kind of the actual usage of Unstruct, right? So you mentioned prompt engineers. So it's the idea that prompt engineers will build these pipelines themselves, right? So as you know, Shuveb, so pipelines, they can break, they need to be tested. So a few years ago, actually, the rise of these data engineering startups for building pipelines for structured data, right? So the DBTs, Fivetrans, Matillions, all of these companies, and then the accompanying orchestration startups, right? So the idea there is, okay, so people are building these pipelines, they break, so these tools are increasingly making it easy for us to diagnose problems and basically start to inject some level of software engineering rigor into how we build pipelines. So now you're doing no code, and there's large language models. There's a bit of a black box going on, right? So how do people make sure that these pipelines, when they do break, and they will break, right? So how do you diagnose? How do you maintain? How do you make sure that you're building it systematically, rigorously, and testing it, right? So
So there's two different phases here. In the first phase is where the prompt engineering is involved, right? So that's the development phase, right?
So can you kind of describe, so when you say the prompt engineering, so it'll be literally, here's a scanned document, and then the prompt will be, find me all of the, something like that, right? So it'll literally explain the kinds of fields that you're looking for.
That is correct. So you're describing the JSON that you want to pull out.
Okay.
And then for each field, you're setting the type of the field. So we would do some extra prompt engineering to enforce field types and things like that. So
this is a prompt engineer who doesn't know how to code who's doing this.
Usually, like I said, it's still an emerging role. We haven't met someone who just came and said, hey, I'm a prompt engineer. That hasn't happened yet, but I believe it will.
But the idea here is these are people who know the data really well.
That is correct. They are domain
they're domain experts.
Exactly, right. So they know the domain. Many a times, of course, we are horizontal, so we don't have any expertise in particular verticals, but we see experts who understand their domain really, really well, and they are the folks who are writing the prompts. So their job really in the design phase, Ben, is to describe the JSON schema they want. So what they are doing is that, see, one thing that's really difficult to do in current generation IDP systems is that intelligent document processing systems is that if there's a wide variety in the same document class, let's say you're passing bank statements and you have 200 different banks from whom you get these statements, it's very difficult to manually annotate these statements. It's very expensive and slow. But when you use large language models, what you do in Prompt Studio, our environment in which you design your prompts, is that you provide a representative sample of these documents. Then we allow you to write generic prompts that work across this representative sample in the hope that these prompts are going to work for, I don't know, the 200 different statements you will see.
As you know, there will be edge cases, so
there will be edge cases all the time.
Yeah.
That's why we have, checks and balances in place.
So this is kind of like the prototyping phase.
That is correct.
Yeah.
Once you do that, all it takes is for you to deploy this as an ETL pipeline or as an API, the same project. And what happens is that you have a unique endpoint to process this document. So if you quite literally post a new document to this endpoint, the response will be JSON data.
But so in the past, right? So you would do that as a data engineer, and then you would look at how your pipeline is doing, and then you have a chance to correct if it's actually not doing what you intended to do. So in this case, is all you're going to end up doing is, okay, so I'm going to run through this pipeline for the sample data. Oh, I noticed it didn't actually do everything I wanted to do. Do I go back? All I can do then is adjust my prompt. That
is correct. So what happens is, because of LLM challenge, because we're using two large language models, if you see nulls in the critical fields that you're supposed to be extracting, you know that the prompts aren't working because these models did not agree, right? So you can go back and make sure that you create a new version of the prompt engine, and then you go ahead and create these prompts, right? And then we keep the integration bit separate from the design phase, so that you quite literally either call an API or you have a ETL pipeline. Again, let's say for example, from Airflow or from any orchestration tool, you can quite literally invoke an API so that the ETL pipeline can be triggered. So all that is there for you to integrate easily with existing tools.
So so right now is the main usage of Unstruct basically simple. Here's a source of unstructured. Here's a corpus of unstructured text, and here's the resulting structured data, and then that's it. So it's a single stage pipeline, basically, right? So
that is correct.
Unstructured to structured.
That is correct. That's how we want it to look. But internally, if you look at it, there's first the raw text extraction happens through LLM Whisperer or any other text extraction service. We integrate with Unstructured.io. We integrate with Llama Parse, so you can use one of those. And then that text is first passed on to one model, and then LLM challenge then comes in, and there's a second large language model. There's also other things like cost-saving features that we have to reduce the number of tokens. So the pipeline internally looks complex, but to anyone using it, it just looks like an API endpoint where they literally post the PDF or whatever it is, and then they simply get back JSON data.
And then so the actual testing is basically just inspecting. Also, there will be some sort of metric when you're in the testing phase. There will be some metric saying, "Hey, ran through all the documents. 60% of this field is null."
Exactly. Field rate.
Something like that. And then it's up to you. At some point, you just pull the trigger. Even if it's 10% null, you say, "Okay, that's good enough."
Exactly. So the fill rate is critical here. And then if you see nulls, that it means that your prompts aren't working for whatever this class of document, right? Wide enough.
And so what percentage of people right now, Shuveb, are using it to get JSON as opposed to CSV, as opposed to sticking it into a national database table?
It's pretty much everyone is JSON. Very rarely do we see people doing anything else with it. So usually what happens is they have some kind of a system they are already using. They're simply making an API call, sending the data over and getting JSON. That's how we see it happen.
So then it's basically, as you mentioned, the intended consumer is machine. So it's a
Absolutely.
machine to machine kind of scenario.
Oh yeah, absolutely. It's not, Unstruct is not built for human consumption at all. It's always machine to machine. It's always JSON. Yeah.
And so then, um, let's see. So what uh, what is actually open source? So what you have a GitHub repo. So
We do have.
can you kind of walk us through as to what is open source?
Oh, totally. So we are most of the features are open. So it's easy to explain what is not open, but let me explain what you can do with the open source project. You can download it, you can run it, you'll have the prompt studio. So you can bring in a representative sample, write generic prompts, launch that prompt studio project as either an API endpoint or as an ETL pipeline. In the ETL pipeline, we have various sources, I think like S3 and Dropbox and Google Drive. And then the destination can be something like a Snowflake or Postgres or MySQL, and like we have a bunch of integrations there as well. So that's fully open source. What's not open source is Ben. LLM Challenge isn't open source, where we use like 2 large language models, and then we have other cost-saving features we call it single pass extraction and summarized extraction, where we use a large language model to take all your prompts, individual prompts, and create a larger prompt so that we can do one-shot extraction. The other feature is where we construct a version of your document, which is a summary, which is then sent over to the prompts. These are both cost-saving features, usually saving up to 6x, 7x kind of cost, right? So these features, 3 features aren't open source.
Um, can you explain to our listeners what LLM Whisperer is?
Yeah. So LLM Whisperer is what we call as a LLM targeting OCR, right? So, and we can deal with real world documents, like for example, scan documents, native PDFs, images, and orientation problems, and all kinds of things, really, right? Like Xerox copies of documents and smartphone pictures of documents, all those kind of things, right? And very importantly, our customers deal with, check boxes and radio buttons and forms. These are very common too. So, but the main thing is that, again, the large language model enables you to not worry about the form of the physical structure of the document you're giving it, because it's taking language as the basic, technology using which we are pulling data out.
But it's an actual OCR. So you wrote your own OCR tool.
That is correct. So
Optimized OCR tool optimized so that the results of this OCR is something that an LLM can take advantage of.
correct. The main thing is that we have something called layout preservation, where we preserve the layout of the input document in the output document. We will quite literally insert spaces to make sure that the output is preserved. And turns out when you have tables, when you have form elements, it just works wonderfully. LLMs very intuitively understand when there's layout preserved. They really understand the input document really well.
And what about charts? Can you guys do charts?
I had 2 requests for charts today from various customers. We don't do it yet because I think the state of the art is not that great. If we even have like a model like 4.0, what we are seeing is that if we just give it a chart and ask it questions, it's very easy to trip it. And we aren't seeing great results yet. So we'll wait for the state of the art to improve. And then, yeah.
So is the ideal use case, Shuveb, for Unstruct that the source documents are relatively somewhat homogeneous in the following sense, right? So they're all receipts and they're all, they're all the same thing. And then you're targeting certain aspects of that document.
That is correct. So think of it like this.
So for example, so you guys may not do this, right? So for example, you can imagine PDF files of research papers, but PDF files of research papers have all sorts of different kinds of layout, right? So some have an abstract page, some have double space, and so on and so forth. So they're all over the map in terms of form. So if that's my starting point, where there's quite a wide variety of what the format is, given that the actual content might be somewhat similar in the sense that there's an abstract, there's an introduction, there's a main body, there's a conclusion, but the layout is all over the place. So that's not ideal for Unstruct, is my question.
So here's the thing, right? First is it's usually for automation kind of use cases. So it's usually machine consumption, right? So a research paper is not a great candidate because it's usually for human consumption, right? So what happens with Unstract is that we excel in areas where there is one class of documents, but then like the example I gave, the bank statements from 200 banks are going to look in 200 different ways, right? So can we take care of that is really where we excel. But yeah.
And so then right now, so you benefit from the fact that there's still a lot of documents that are scanned. Is that right?
Absolutely.
So at some point, if the document is digital, if the source is already digital, but unstructured, is that not a good use case for you?
No, it is okay. So take for example, I don't think that will ever get solved because take for example insurance claims, right? You're gonna get claims from different people. You're gonna get like a bunch of documents. Or for example, you're applying for a loan, they're gonna ask you for a bunch of documents. Anytime any BFSI company, healthcare company, legal organization interfaces with the outside world, you're bound to have a lot of unstructured data. And so we usually look for two V's, Ben. The first V is it valuable? It's not like a cheap use case. It's super valuable. It's a critical business process. The second V is volume. It's a business that's processing a lot of those documents. And see, what happens is that if that particular business, right, they may not be able to take on more business because it's a manual process. By automating this thing.
I was just thinking through this variety question I asked you, and here's one workaround, right? So if you had some tool, let's say I have a pile of documents and the relative formatting is all over the map.
Yeah.
If you had some tool that step one, it clusters it and so that hey, these documents kind of look alike, these documents look alike, and then you can develop prompts, individual prompts for each cluster somehow.
Oh yeah, we already have that. So we in fact we use large language models to actually categorize the document into various folders, and then go ahead and do extraction from it. So it's a very common thing. In fact, the worst thing is they would send us one document which has 20 documents inside of it. That's very common too. So we see that all the time.
So the actual information extraction. So you have LLM Whisperer, which is basically your OCR optimized for LLMs, right? So then now you have the text. So the actual information extraction from that text to structured data.
Yep.
Is that something you folks do yourself, or do you rely on external libraries?
So the two phases are the raw text extraction is where LLM Whisperer comes in, Ben.
Yeah.
And then the raw text to the JSON formatting happens through Unstruct, the Unstruct platform.
Okay, so but for example, if there's entities in there, you just completely rely on the LLM to extract all the entities.
That is correct. And
So
it
you're
works.
only as good as the entity extraction capabilities of the LLMs, which can be good, but won't be
Yeah.
as good as a fine-tuned model that is searching specifically for the type of entities that you are targeting, right? So,
No, that's a great point. So that's why we always advise customers to, have, let's say, around 1,500 manually verified extractions. If needed, they go and correct some of the mistakes that, an initial project would have made. Then we use that to fine tune something like Llama 3. And then one super
but
important
then
thing is,
Llama 3 is part of the mix in terms of this that gets evaluated. So Llama
yeah,
3 is one of the models that starts suggesting answers.
sure. And
Yeah.
then we use those answers, manually verify them, and then we
Mm.
split that into like a training set and a testing set, and then we fine tune the models. The very important thing is that we don't ship with any LLM at all. So it's really up to the customer to, like, we call it a quad. So they'll have to choose a large language model, a vector database, an embedding model, and a text extraction service. And you can choose whatever you want.
All right. So LLM, you can choose either proprietary APIs or one of these many endpoints that uh, offers open source models that you can fine tune, right? So Anyscale, for example, has a great
That is correct.
simple to use fine tuning service.
Mm.
Vector databases, there's many that are now easy to use on a SaaS basis,
Yeah.
right? So what about text extraction?
So we support, of course, LLM Whisperer, which is our own service. We also support Unstructured IO and Llama Parse.
Okay. So LLM Whisperer is more than an OCR tool?
Absolutely, because we'll have to we so think of it like this, right? When we have 30, 40 different techniques, so we'll do things like computer vision. We have machine learning models to detect checkboxes and radio buttons. Then we have models to take care of the OCR, the actual OCR itself, and the layout preservation is another technique that we use. All this is part of LLM Whisperer.
Huh, interesting. So let's say I
So
give you
coming
a
to
let's say I give you a talk at a conference, right? So and I give you 4 slides to boast about your favorite use cases for Unstruct. Uh, what would those 4 slides be? You don't have to name customers. You can just describe the actual use case.
oh, totally. So contracts are very common, so all sorts of legal contracts, SaaS contracts, these are all at scale use cases that we have, right? And then a lot of BPO kind of use cases, mainly. So BPOs are buying software from us because they are constantly processing things like legal documents and things like insurance related, mortgage related. So BFSI is really, a top use case. And then we are slowly getting into healthcare. There's a lot of, friction there, but we are already HIPAA compliant. So those would be some use cases like protocol, clinical protocol trials, and those kind of documents. And these are some top use cases we see.
And so as you said, so the common thread to all these use cases is you have a bunch of unstructured text, you extract as much information out of this unstructured text, but render that information in structured format. And then that's it. That's the end of your service. And then the user or the client does whatever they want in terms of what they do with those JSON files or those CSV files and whatever application comes after that, right? So
That is
some
exactly.
of those in some domains, so for example, in healthcare, like you said, I mean, you have to get it right, right?
Oh, yeah.
So so it would be so you really need to Unstruct has to really put in place a process where you can really QA and test and make sure that the pipeline is behaving as intended, right?
Yeah, absolutely. So the usual thing is there's a lot of friction when we go talk to some of these teams, right? So you mentioned that, oh, you do this like really sharp, very narrow focus. That's correct. And that's by design. Because look, we are platform builders. We don't have any vertical expertise, even if we had to do it, right? So we don't have any finance expertise or healthcare expertise, any of that stuff, right? So what we are doing is what we are telling engineering teams is that, hey, this is undifferentiated work. Document in JSON out is the only thing we do, but we do it really well. And if there's a mistake a large language model is making, we'll make sure that's not passed on into the JSON because of whatever tests and checks and balances we have. They usually, when we talk to them, there's a lot of friction. They say, hey, we're building something like this internally, and then oh man, we don't want to use your system. But then when they start using it, they realize that, hey, a lot of the cost saving features, the LLM challenge feature, these are some things that are better there rather than for them to put effort into. And then if there's a system where they get clean data, they can use it to train their machine learning models or use it downstream. And this becomes like a very thin, very sharp layer.
So I suspect that even though you position yourself as no code and that the typical role is prompt engineer, ultimately, I would suspect someone technical is actually using uh, Unstruct because basically at some level, it's still kind of, there's still some fiddling and testing and checking that needs to be done. And I don't know if I'm comfortable passing that to just a domain expert.
Absolutely. So the domain expert can only do the prompt engineering bit.
Yeah.
After the Prompt Studio project is launched as an API or as an ETL pipeline, you will have to bring in the engineering folks to do the integration. But there's no doubt about that. It's like also right. Prompt engineering today, it's the engineers who are doing it. We're not seeing, yeah. So that's what we see. Yeah.
So in terms of broader developments, Shuveb, I mean, obviously these models are increasingly, we call them LLMs, but they're increasingly becoming multimodal models, right?
Oh
So
yeah.
is there anything about the multimodality it seems like that you folks can exploit, right? Because if the model is, if as these models become truly multimodal, then maybe you can really benefit from its ability to really even make sense of images.
Exactly. You mentioned that before as we spoke. So today, LLM Whisperer can detect tables, and we are adding support for images and charts and things like that. But like I told you, even this morning we were looking at a simple bar chart, which like a grade 4, grade 5 child can very easily explain. But GPT 4.0, for example, did not do a good job, and it's not there yet, is what we would say, right? So, but it's a very common ask, man. People constantly ask us, "Hey, today there were two asks. Hey, we have charts. Can you interpret that and give it to us as JSON or?" But we are like, no, it's just not there yet, right? So yeah.
And then at some point, obviously, audio and video. But audio and video, I guess, for audio, you just first turn it into a transcript and then maybe you can do your thing. But video, sometimes in the video itself, as for example, if I'm giving a talk and it's a video, maybe I'm kind of pointing out things in my slide that a simple transcript will miss, right?
That
And
is true.
as these models increasingly become capable, uh, then you just benefit. So I think part of what I'm getting to, Shuveb, is if Unstruct is designed properly, then it benefits from developments in the foundation models itself, right?
Totally, totally. When the no doubt about that, and hopefully we did design it properly. And yeah, you're absolutely right. Especially the multimodality around charts and figures. That's a very, very common ask.
So again, so in closing, Shuveb, so for the open source project, um, what's the degree of usability compared to the paid version, obviously? So if I just go to the open source project, um, what should I expect in terms of uh, level of usability and documentation and all these things? So for our listeners who may not be ready to try the paid version but want to really play around with the open source version, are there any specific tutorials or parts of the documentation you want to point them to?
Oh, totally. So the documentation comes with a getting started guide, which is exactly the same for the open source version and the hosted version. The hosted version only has certain enterprise plugins, really. Ben. Otherwise, you think of it like this, right? So when we build our enterprise version, we take the open source version, we add a couple of plugins, and it goes into the cloud. That's all we do. And there are certain cost saving features and accuracy features apart from SSO that we have in the enterprise version. Otherwise, the open source version is our base. That's how we want to keep it too.
And so any data type or data source that works in the paid version is supported by the open source.
100%. All the integrations are there.
Okay. And with that, thank you, Shuveb.
Thank you so much.